assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
So in this problem, we have Fe3 plus ion, which has a coordination number of 6, and that's why it will be an octahedral complex. And so the question here is whether to form this Fe3 plus from an Fe atom, which has an electronic configuration of Ar and then 4s2 3d6. So the question is to form this Fe3 plus, whether the electrons are first removed from this d orbital or from the s orbital. So if the electrons are first lost from the s orbital, we will have an Fe3 plus electronic configuration of argon and then 4s2 and 3d3. And what will be our the crystal field splitting diagram for this? As we know that for octahedral complexes, crystal field splitting takes place like this. And since we have only 3d electrons, we'll have a diagram like this. So that means that that's the only possible diagram for Fe3 plus in case of the electrons getting lost from s orbital. And that means that whether the complex is low spin or high spin, whether the ligand is strong field or weak field, that will not actually affect the electronic arrangement in the orbital splitting. And that's why we will not be able to say anything about the magnetic properties of the complex. But if the electrons are lost from the d orbitals first, if the electrons are lost from s orbital first, then we will have an Fe3 plus electronic configuration as argon, and then 4s2 will get rid of these 2 electrons and 1 of these, and we'll have 3d5. And in that case, we'll have 2 possible crystal field splitting diagram. So since we have 5 electrons here, in one case, we'll have all of them occupying both the lower and higher energy state orbital to form or to give us 5 unpaired electrons. And in another case, we will have electrons only occupying the lower energy state orbital pairing up to just give us only 1 unpaired electron. So we know that this case happens when the ligand approaching is a weak ligand, and that's why we will have a high spin complex. And this is possible, or this happens when the ligand is a strong ligand and we have a low spin complex. And we know that the number of unpaired electrons is the main fact with which we actually explain the magnetic properties of a complex. So that means that only if the electrons are removed from the s orbital first, then we can have these 2 different types of crystal field splitting diagram from which we can explain the magnetic properties of the complex depends on the field strength of the ligand. But if the electrons are removed from the d orbitals first, then we will have this orbitals splitting diagram from where we cannot explain the magnetic properties and its dependence on the field strength of the ligand. That's why the idea of getting the s electrons removed first is valid, and that is supported by the explanation here.